Exercise 7.2 Problem 5 discussion. A single pendulum of length 40 cm subtends 60 degrees at the vertex in one full oscillation. What will be the shortest distance between the initial position and the final position of the bob? Okay, so this is a simple diagram. So this is where the pendulum is fixed and it oscillates like this. Okay, so this is, let's say this is the initial position and this is the final position, and this is the equilibrium position. Equilibrium position means when after oscillation it stops and comes to rest at this point. It is vertically downwards, right? Normally we know that whenever you hang anything, it will come to the vertical position, right? So this is the equilibrium position, and when it oscillates, it goes up and comes to one point and then returns back in the direction. So this is the, let's say this is initial position, it goes here, after reaches this point B and then returns back. So this is the oscillation, right? And it subtends. So if you draw a line, initial position, and if you say, actually it's not initial position, it's not right. This is the two extreme positions. This is one position extreme and this is another extreme position. And the angle it subtends at the center is 60 degrees altogether. It draws 16 degrees, 60 between this angle is 60 degrees at the vertex. But we know when you at the equilibrium position, the pendulum will be in this direction along AC, vertically downwards, and it will divide that 60 degrees into two parts. It will always oscillate from here equally in both directions. Okay, if it goes 10 centimeter in this direction, and it will also go 10 centimeter only, or it goes 30 degrees here this side, it will also go 30 degrees. It won't go 30 degrees here one side and 40 degrees other side. It does not go. It goes equally, right? So this angle is 30 degrees and this angle is 30 degrees. Got it? Now, and we also know that the length of the pendulum is 40 centimeter. So this length AB and AD is 40 centimeter. Okay. Now, what are we asked? We are asked to find the shortest distance between the two extreme position or initial and final position, that is between B and D. This is the shortest position. So the pendulum oscillates like this. It comes to B, then goes back and reaches D, again it comes back B. So these are the two extreme points. What is the shortest distance between any 2 points? You just join those 2 points. A straight line between 2 points is the shortest. So all they are asking is the shortest, which is nothing but BD. So we need to calculate BD. But from this triangle ABD, you know, see this angle, this is 30 degrees, this is 30 degrees, this is 90 degrees, this is 90 degrees, right? And which means by AAA, these two are equal, and in fact both of them are congruent. Basically these two triangles are equal triangles actually. So if we calculate BC, then BD is nothing but 2 times BC. Okay, now let's concentrate on calculating BC. What is BC? BC is the one we want to calculate. This is given and this angle is known. What is sine 30? Opposite by hypotenuse. That is sine 30, which is half, equal to BC divided by 40, and you'll be able to calculate BC. Once you know BC, twice of BC is CD. Okay, so this is how it needs to be worked out. Let's see it one more time step by step. So what is given? The length of the pendulum 40 centimeters. This is the pendulum in the initial one position, extreme position, and another extreme position, it is the same length. Okay, and it subtends 60 degrees. So it subtends between the initial and the final, or two extreme. It subtends altogether 60 degrees. But I've divided it into two because this is in equilibrium position, it will come straight. So it will be two parts, two equal parts. So 60 is divided into 2, 30 by 30. Right? Then what will be the shortest distance? So that is what they are asked. Shortest, these are the two extremes, initial or final, and they are asked to find the shortest distance, that is BD. Okay? Right. What is given? Length of the pendulum 40 centimeter. Angle at the vertex 60 degrees. Okay. Next, we need to calculate the shortest distance between the initial position and the final position. That is B and D. So what is the shortest distance? It's a straight line. Right. The formula is, as I said, we can divide this into two triangles. Then you can apply sine 30. Sine 30 is opposite by hypotenuse. Okay, draw a rough diagram, label and mark the diagram with given values. Substitute the values of theta, half the angular vertex, length of pendulum, in sine theta equal to opposite by hypotenuse, that is equal to CD by length of pendulum, and calculate CD. So what we are saying here is that now we consider this triangle only. Okay, I should have probably written in the triangle ABC. Please add this. In the triangle ABC, substitute the value. Okay, so in the triangle ABC, sine 30 is opposite by hypotenuse. That is BC. Or okay, we are taking, and in the formula I'm taking this side. So we are considering triangle ACD, right? And in that opposite side is CD. CD divided by hypotenuse. Hypotenuse is nothing but 40 centimeter. So sine 30 equal to CD by length of pendulum, that is 40 centimeter. So this is known, 40 centimeter. The sine 30 is half known. So which means this can be calculated. So we can calculate CD. So once you know calculate CD, twice CD is BD. Okay, because this and this are equal lengths. Okay, so BD is 2 times CD. So this is how this problem needs to be worked out. So you have to go through this one more time because it's a little difficult to understand. But if you go through, it will be easy. Once the diagram is done, half the problem is solved. Okay, so I suggest you stop the video here and try to work this problem. And on completion, please come back and check your working against our solution. Okay, solution. So let B and D be the initial and the final position of the pendulum. The length of the pendulum is 40 centimeter. That is AB, AD equal to 40 centimeter. Angle at the vertex is 60 degrees, and that we are dividing into 2 by drawing vertically vertical line, and that divides that vertex into 2, 30 degrees and 30 degrees, and join these two lines BD, which is the shortest distance, and that is what we need to calculate. Right now, in the triangle ABC, okay, sine 30 equal to opposite by hypotenuse. So that is, so opposite is BC and hypotenuse is 40. So substitute all this value. So sine 30 is half, right? We are putting this half. BC we don't know. BC is what we need to calculate. And what is AB? AB is 40 centimeters. So BC by 40 equal to half, or BC will be equal to half into 40. And half into 40, this 2 will go 20 times. So you'll get 20 centimeter. So the shortest distance between the initial and the final position is 2 into 20, because this is 20 and this is also 20. So 2 into 20, that is equal to 40 centimeter. Okay. So I hope I made it clear. If not, please go through this video one more time. It will become clear. Thanks for watching this video.